Hi everyone, welcome back. We're talking about renal tubular reabsorption. So previously we spoke about how our kidney reabsorbs glucose, amino acids, then sodium, water, bicarbonate, chloride, right? It reabsorbs all of these things. Now there's an additional thing. Kidneys also have a function of metabolizing low molecular weight proteins. Now, you may be wondering, what are these low molecular weight proteins? Okay, we initially established that all of the plasma proteins and the substances which are bound to plasma proteins, they do not get filtered. Yes, that's a stated fact. इसमें कोई changes नहीं है. All the plasma proteins and the things that are bound to plasma proteins, they do not get filtered. Or plasma proteins, if I remember, if I can recall, I did mention albumin, globulin, fibrinogen. Or albumin being the smallest, fibrinogen being the largest, albumin का size was just fit, लेकिन it had a negative charge. और हमारी filtration membrane का charge भी negative था, so it repelled, and that's how albumin didn't get filtered. लेकिन there's some plasma proteins which are even smaller than albumin. Now you may be wondering what are those plasma proteins. So a hint is that it is an endocrine hormone, and I'm sure you can already see on the screen. So the answer is insulin. Insulin is a plasma protein, or you can say hormone, which is smaller than albumin. So there are high chances कि ये भी filter out हो सकता है और होता भी है. And then also hemoglobin. Now hemoglobin, I already told initially, it's cytotoxic. But thankfully, it's packaged in RBCs, and that's how it's not filtered because all the red blood cells, white blood cells, plasma, kabhi I told you, only the fluid portion gets filtered. उसका cellular portion, which was 45% of the blood, वो नहीं filter out हो रहा था. तो RBCs के अंदर packaged होता है hemoglobin, and that's how it doesn't get filtered. But in the cases of incompatible blood transfusion, for example, if someone is given a blood group that he doesn't actually own, or उसकी transfusion हो, blood in that is basically incompatible blood transfusion, right? So the blood groups are going to react together, and what will happen? The RBCs will start rupturing, and hemoglobin, it will be freely flowing, and free flowing hemoglobin is very dangerous. Now when that hemoglobin comes to the renal blood flow, it gets filtered out, बिल्कुल ऐसे filter होकर नीचे आता है, and our proximal coronary tubule के epithelial cells are so silly, they think कि अच्छा कोई gift आ रहा है, and they start capturing this hemoglobin. लेकिन जब ये hemoglobin अंदर जाता है, it breaks down into iron. That iron starts producing reactive oxygen species and radicals. ये radicals will start reacting with the proximal coronary tubule का epithelial cell. Once they start reacting with it, necrosis होगी, blood flow stop हो जाएगी, necrosis हो जाएगी, and this entire cell will stop working. That means your kidneys are being, उनके cells are being destroyed. So this is acute tubular necrosis. Acute tubular necrosis. Now, yes, moving forward, most of our low molecular weight proteins are catabolized to amino acid by proximal coronary tubule cells. So in the time of need, proximal coronary tubule cells can also do gluconeogenesis, right? Because all of the low molecular weight proteins that are recaptured वो amino acid में transfer होते हैं, they're converted to amino acid, and that amino acid is converted to glucose. So that's how gluconeogenesis happens only in times of extreme need. ठीक है? अब मैंने ये तो बता दिया कि लो मॉलिक्यूलर वेट प्रोटीन जैसे हीमोग्लोबिन और इंसुलिन ये फिल्टर होते हैं, हाँ ये फिल्टर होते हैं, लेकिन क्या ये जाकर आगे यूरिन में चले जाते हैं? नो, दे नीड टू बी रिकैप्चर्ड. सो देयर शुड बी सम मैकेनिज्म जिससे ये रिकैप्चर हो. दे हैव टू बी रिकैप्चर्ड. हाँ, हीमोग्लोबिन तो खैर दिस इज अ पैथोलॉजिकल केस, लेकिन ये फिजियोलॉजिकली दे शुड बी रिकैप्चर्ड and catalyzed in the kidney itself. अब हमें already I told you कि we have active transport to help us with a lot of recapturing, जिसमें primary active transport था. Primary active transport तो खैर sodium potassium ATPase pump है, but that also indirectly does help us with recapturing. Then you have secondary active transport जिसमें glucose and amino acid जो sodium or glucose का what was that co-transport, and then you had amino acid, sodium and amino acid का co-transport. That was secondary active transport. Then also sodium and chloride का co-transport, that was also secondary active transport. And right now we also spoke about bicarbonate की secretion, bicarbonate की नहीं, sorry, protons की secretion, that was also secondary active transport. अब pinocytosis, what is pinocytosis? होता क्या है कि ये आपका ट्यूब्यूल है, ठीक है, tubular lumen, and this is your proximal coronary tubule के epithelial cells. बाहर से you were having the plasma proteins, the small plasma proteins, जो बिल्कुल low molecular, चलो मैं low molecular weight proteins लिख देती हूँ, it's not appropriate to write that. अच्छा, अब होता क्या है कि these low molecular weight proteins will come and they'll start attaching on this side of the epithelium, ठीक है, this is the luminal membrane, right? Luminal जिसके ऊपर you have these enfoldings, brush border. अच्छा, यहाँ आकर आपके लो मॉलिक्यूलर वेट प्रोटीन्स लगते हैं। अब अंदर से वी हैव अनदर वेरी फैसिनेटिंग थिंग कॉल्ड क्लेथरिन। अब ये क्लेथरिन जो है ये अंदर से ऐसे लगेगा। जब क्लेथरिन अंदर से लगेगा, व्हाट विल हैपन, इट विल स्टार्ट पिंचिंग, इट विल स्टार्ट पिंचिंग दिस membrane inwards. जब ये membrane inwards pinch होगी, so basically what will happen, let me erase this here, what will happen is that के ये this thing will get stored in the vesicle, और क्लेथरिन ने उसे pinch कर दिया and this will be pinched off and ultimately you will get a वेसिकल। तो इस तरह हमें एक वेसिकल मिल गया। अब उस वेसिकल के अंदर क्या स्टोर है, इंसुलिन। सो दिस इज द मैकेनिज्म जिससे पाइनोसाइटोसिस होती है। So this is basically it. How the proteins, especially low molecular weight proteins, are taken into the proximal convoluted tubule cell. If they ask you, so this is the mechanism. Pinocytosis is the mechanism, right? Now moving forward, इसमें इतनी ज़्यादा कोई डिटेल की जरूरत भी नहीं है। there's this phenomena of Tmax और ट्रांसपोर्ट मैक्सिमम। ट्रांसपोर्ट मैक्सिमम क्या होता है और कौन सी सब्सटेंसेस हैं जो ट्रांसपोर्ट मैक्सिमम को फॉलो करते हैं? सो मोस्ट ऑफ द सब्सटेंसेस दे डू फॉलो ट्रांसपोर्ट मैक्सिमम, क्योंकि मैंने आपको बताया था, इफ यू कैन रिकॉल सोडियम, फॉर एग्जांपल लेट्स से सोडियम अमीनो एसिड एक्सचेंजर, तो there'll be a certain amount of sodium amino acid exchanger or sodium glucose exchanger. अब अगर that person is diabetic and there's a lot of free flowing glucose, इतना ज़्यादा glucose आ रहा होगा, लेकिन इतने तो sodium exchangers ही नहीं है, sodium glucose exchangers ही नहीं है जितना glucose आ रहा है। At one point all of these will be concentrated, लेकिन अभी भी इतना glucose होगा जो अभी भी the present होगा, and that will be begging for these exchangers to take them up. Exchangers नहीं, co-transporters है। तो वो उनको बेग करा होगा कि प्लीज टेक मी अप, लेकिन ये सारे occupied and they all are concentrated। और वैसे भी GFR means that it's flowing rapidly, तो इतना टाइम ही नहीं होगा कि it can sit here and wait, so that all the entire glucose will start being, मतलब जितना भी remaining glucose है that will start being excreted in urine, and in a healthy individual you won't see glucose in urine, right? You won't see glycosuria, लेकिन in diabetic patients there is glucose in urine. So that is when, that's the thing of transport maximum. Okay, glucose can reach its transport maximum, especially in diabetic patients. So all those substances that are reabsorbed from luminal side to the cellular side, special transport proteins are there to help them be reabsorbed. But these transporter proteins, they display the phenomena of transport maximum. This is that they can get saturated. But there are some substances which do not follow the transport maximum phenomena. Why is it so? For example, sodium, क्योंकि इसके it has several ways of being reabsorbed, right? You have sodium glucose co-transporter, you have sodium amino acid co-transporter, you have sodium chloride co-transporter, and even solvent drag may be sodium reabsorbed. So there are a lot of ways for it to be taken up, and then ये तो सिर्फ proximal convoluted tubule है ना, eventually आगे जाकर if you see distal convoluted tubule, उधर भी with the help of principal cells sodium can get reabsorbed. So उसके several ways हैं, so it doesn't follow the phenomena of the transport maximum. Now, aldosterone. Aldosterone is such a wonderful hormone. What it does is it increases sodium and water reabsorption. ये इनकी reabsorption को बढ़ाता है. This is something that you need to know. ठीक है? अब ये कैसे करता है? उसका पीछे जो पूरा mechanism है, it's so beautiful and it's so intricately designed कि ये बेसिकली हमारे सोडियम पोटेशियम एटीपेज पंप जो हैं उनकी एक्टिविटी को भी इंक्रीज करता है और उनके नंबर को भी इंक्रीज करता है। व्हेन देयर आर लॉट ऑफ सोडियम पोटेशियम एटीपेज पंप एंड व्हेन देयर एक्टिविटी इज अ लॉट, सो दिस मींस कि ज्यादा से ज्यादा सोडियम इज बीइंग पम्प्ड आउट, राइट? It's being thrown out. So this region of the intercellular region that will be more and more sodium poor. जब ये बहुत ज़्यादा sodium poor होगा तो बाहर से excessive amount से sodium अंदर जाएगा। excessive का एक बहुत अच्छा gradient establish हो गया। So a high concentration gradient has been developed between tubule and the cell. Therefore, there will be increased sodium reabsorption. So that's how a lot of sodium is reabsorbed, all thanks to aldosterone. And under the direction of aldosterone, principal cell increases the synthesis of sodium potassium ATPase and hence its activity increases. और ये किस पर act कर रहा है? Principal cell पर, ठीक है? Now, sodium reabsorption, it depends on concentration gradient. हाँ, concentration gradient पर depend करे, electrochemical gradient पर भी depend करे. This all I already told you कि inside you have electronegativity, बाहर positivity होती है और sodium भी positive ion है. It's basically a cation, so it gets taken in. And also contact time. अब contact time का मतलब क्या है कि अगर GFR ज़्यादा है तो fluid ज़्यादा तेजी से move करेंगे ना, they'll keep moving forward. तो उनका इतना टाइम ही नहीं होगा कि वो reabsorb हो सके. So the reabsorption will be poor. लेकिन अगर कॉन्टैक्ट टाइम ज़्यादा हो, वो कब होगा contact time ज़्यादा, जब GFR लो हो, जब GFR लो होगा तो the fluid will be moving very slowly, contact time will be more and there will be very good reabsorption. So sodium reabsorption मैंने बोला था कि sodium isn't dependent on Tmax, इसका ये Tmax का फॉर्मूला फिनोमेना फॉलो नहीं करता, concentration इसकी exchanges की full हो ही नहीं सकती, या co-transporters की full हो ही नहीं सकती, they cannot be saturated all at once. But this depends on these three things: concentration gradient, electrochemical gradient, and contact time. Now moving forward, ग्लूकोज और अमीनो एसिड ये सब टी मैक्स के फिनोमेना को फॉलो करते हैं, जबकि सोडियम क्लोराइड का इनके देयर इज मल्टीपल वेज इन व्हिच they can be reabsorbed, and they can be reabsorbed from different parts of the nephron. Therefore, they show the gradient. What do I mean by gradient? Concentration, electrochemical gradient, and contact time dependent transport. So yeah, that's pretty much it.